Alright, let's go ahead and check out an example from chapter 10.1, which is based on determining confidence intervals for the difference between population means. So we're going to look at 10.1.1, which is the first problem from your 13th homework assignment. Based on the sample information, determine a 95% confidence interval for the difference between the two means. And we're told that sample size 1 is 12, sample mean 1 is 59, sample standard deviation 1 is 6, and so on, right? Now, I just want to review back. Whenever you're finding a confidence interval, the general formula is just the point estimate plus or minus a critical value multiplied by a standard deviation or a standard error. So now, let's basically write a formula now for figuring out the confidence interval for the difference in means. Now, your point estimate for the difference in means makes sense, is just going to be your first sample mean, subtract out your second sample mean. Makes sense, right? Point estimate for the difference between those two means. Now, plus or minus. Critical value. Now, in this case, since we only have sample standard deviations, instead of having a z critical value, in this case we're going to have a t critical value. So I'll just write out t critical. Now, the standard deviation for the difference between the means is a little bit complicated. And here, let me write out the whole formula for that. So it's sample size 1, subtract 1. That is multiplied by sample standard deviation 1 squared, or the sample variance 1, plus the quantity sample size 2. Subtract out 1, multiplied by the sample standard deviation 2 squared. And that's all divided by sample size 1 plus sample size 2. Subtract out 2. Then that is multiplied by another radical expression that is just 1 over sample size 1 plus 1 over sample size 2. So now the real issue is just plugging in the values, right? Of course, we already have x bar 1, x bar 2. That's going to be 59 and 62. Bring down the plus or minus. Now, the t critical value. When you're finding the t critical value, of course, it's based on the degrees of freedom and the confidence level. Now that we have two different sample sizes, to figure out the degrees of freedom, we take sample size 1 plus sample size 2, and then instead of subtracting 1, we subtract 2. So in this case, 12 plus 18 is 30. 30 subtract 2 is 28. So then you look up on your table where the degrees of freedom is 28 for the 90% confidence level, and you should get a t critical value of 1.7011. Then fill in the rest of this. Sample size 1 is, of course, 12. So we have 12, subtract out 1, multiplied by sample standard deviation 1 squared, or 6 squared. Bring over the plus, and that's multiplied by sample size 2, or 18. Subtract out 1, multiplied by its sample standard deviation squared, or 5 squared. Then, of course, divided by n1 plus n2 minus 2. 12 plus 18 minus 2. Then that's all multiplied by the square root of 1 over sample size 1 again, 12, plus 1 over sample size 2, or 18. So almost there. Now basically all you have to do is put it in the calculator. Of course, the minus is going to give us the lower bound of the confidence interval. The plus is going to give us the upper bound of the confidence interval. So when I take this minus all that, I end up with negative 6.43. And of course, we are estimating the differences between the two populations. And then to get the upper bound, of course, you take that value plus whatever that is, and I got negative 0.43 for that. So, if you want to summarize what this means, is that you can be 95% confident that 90% confident that the difference between the population means is between negative 6.43 and negative 0.43. Or basically that population 1 is between 6.43 and 0.43 units lower than population 2. And bam, we got it. Alrighty, let's go ahead and check out another example problem, which is the concern of calculating a confidence interval for the difference between two population means. And this is example 10.1.13, and it is number 6 from your 13th homework assignment. I wrote up all the important information right here, but just let me read the original problem statement to you guys. A popular Italian eatery has a dispute among the wait staff regarding the amount of tips waiters receive on the lunch shift and on the dinner shift. Before making any adjustments to the schedule or other policies, the restaurant manager wants to estimate the difference in the average tips earned by waiters on the lunch shift and on the dinner schedule. To do this, she randomly selects 50 tip reports from the lunch servers over the past year and 40 tip reports from dinner servers. The results given below were observed. Assuming equal population variances, develop and interpret an 80% confidence interval estimate for the difference between the population mean tips earned by lunch servers and by dinner servers. So we were told that sample size for lunch was 50, sample size for dinner was 40, and then it gives us sample mean, sample standard deviation, sample mean, sample standard deviation. And of course, we want to go ahead and construct a 80% confidence interval for the difference between these two population means. Now, I already wrote down the formula for the confidence interval for the difference between two population means. Notice we have a t critical value rather than a z value, and again, that's because we're based on sample standard deviations rather than population standard deviations. Then, of course, this whole area right here, which is the the standard deviation or standard error, of course, that formula is quite a bit more complicated. So let's go ahead and start filling out values. Of course, sample mean 1 is 56.40. From that, we want to subtract out sample mean 2, 103.90. From the formula, that's going to be plus or minus. Next thing we need to do is come up with our t critical value. Again, our t critical value is based on the degrees of freedom and the confidence level. So, since we have two different samples here, the degrees of freedom is sample size 1 plus sample size 2, which is 90, subtract 2, which is 88. So we're going to look up degrees of freedom of 88 at the 80% confidence level, and I got a T critical value of 1.29. Now, of course, we just need to plug in all the rest of the information for the formula. Sample size 1 is 50. Subtract out 1. Sample standard deviation 1 is 11.5. Plus sample size 2 of 40. Subtract out 1. Multiplied by its sample standard deviation of 12.17 squared. Then all divided by n1 plus n2 minus 2, or 50 plus 40 minus 2. Multiplied by then the square root of 1 over sample size 1 plus 1 over sample size 2. Of course, we're going to get our lower bound by subtracting this, upper bound by adding it. So first off, when I subtracted, I got negative 50.73. And of course, that's going to be less than or equal to the difference between the population means. And then when I added this value, we got our upper bound, and that came out to negative 44.27. So what this means is that we can be 80% sure that basically the dinner shift makes between 5073 and 4424 more each shift. These are negative because, of course, we're taking the lower value, subtracting out the positive value. But if we just switch those around, of course, we have positive values. So let's see, what did they ask? The mean tips earned are not the same thing during lunch and dinner, basically because this confidence interval does not include a 0, right? And good to go.